Hello, welcome to this video. Today I will show you how to analyze bone cavities with the Imalytics Preclinical software. I will open the software first and then we will load an example dataset under CT, bone cavity, load example dataset. And let me open the 3D rendering for you. But first I will close the segmentation because we don't need it at the beginning. And also I will hide the overlay. Okay, let me open some other orientations for you. And what we see in the scan is it's a micro CT scan of a piece of cortical bone, and it has these cavities here. Here and here. For example, this match shape cavity. And in this video I'm going to explain you how to skeletonize this cavity and compute the cross-sectional area orthogonal to the path, and also the largest fitting sphere inside as a statistic readout. So let's start by segmenting the cavity, and we can do this using thresholding and fill region operations. So let's pick a threshold that is suitable. You can find a threshold in the right corner, so here. And inside it's around 0 and outside 200. So let's add a class temp. And then perform a thresholding above, let's say 100. Okay. But not above, sorry, I mean thresholding below 100, because we want to segment the cavity. Okay, and let me hide the underlay for a second. So it's meant as this part, and to only get the cavity, let me add a class cavity and perform a fill region operation. You can find it here in the mouse action toolbar. Just press inside, and now the cavity is segmented. Let me delete the temp class, and when we go a little bit, have a closer look, you can see that this piece here doesn't belong to the cavity. We have two options to delete it. You can use these scribbles and go here to the connection, and then you can cut it by here, for example, drawing scribbles and F2. But you can also use this draw segmentation operation, and this is my favorite. Therefore you have to set cavity as input class and unclassified as output class. And you can use the draw segmentation also in 3D. So like this. And cut the connection. And then we can perform a fill region. And now this piece is unclassified and we have only the cavity left. Okay. And now we can perform a skeletonization of the cavity by using the bone module, single bone skeletonization of input class. We can save it under bone skeleton. So I save it as a CSV file, and then it says skeleton has been computed, path is shown, please use undo to restore the input class. Okay, let me hide the underlay. We can make it a little bit thicker, this path, by morphologic dilate with 1. Okay. And so the path that has been computed as a skeleton is saved in a CSV file. I will open it in a second. But for this we don't need it anymore here, so I will undo it and go back. Okay, but let me open the CSV file. I called it skeleton. Didn't work in this case, but I already prepared it. So this is the skeletonization for class cavity. And what you can see here are a lot of columns. And the first column here is the position along the principal direction in millimeters. So the software computes the direction in 3D. Let me show you this in the software. Here. Whoop. So the software computes the direction in 3D, the principal component direction of the segmentation, and then computes the cross-sectional area orthogonal to that principal direction. So here. And we can plot this with Excel. Let me generate another chart like this. I already prepared it, but that you can see it how it works. And this is the area in square millimeters along the class. So you can see here that it gets bigger and it's a larger area. You can, when you shift the column to this, also see the sphere radius, and it's a similar readout, but it's in millimeter in this case. And it's the largest fitting sphere inside the cavity, but let me explain what it is. So let's compute a distance map here. Under vascular distance map inside input class, like this. And now we can see here this distance map as overlay. So let's hide the segmentation. It's here. Yeah. And this shows the values of the largest fitting sphere contained in the input class. And to test if this works accurately, you can load an existing segmentation. So let me open the dataset again, because I showed you at the beginning we already have some segmentations here. Here in yellow is a match shape segmentation, and in green a very nice cylinder, or a perfect cylinder. And you can measure the diameter of the cylinder here in millimeters and compute the known radius, or you can even generate a new cylinder with the create region function. You can find it here. And then you can compute the statistics for the cylinder and check if the results are correct. And I already did this, and this is how it looks. Here are the cavity, the cylinder, and the matchstick shaped region. And you can see here the cross-sectional area along the principal direction. And here for the segmentations in yellow, you can see this match shape one, and in green for the cylinder. And you can see that we have the same distance map values, which represents the largest sphere radius that fit at each slide. Yeah, also here. Yeah. And that's all about analyzing cavities for today. I hope that helps. If you need some further information, please check out the white paper. There are also some more information about this kind of calculation here. And I hope this helps. Thanks and bye-bye.